Hello, everyone, and welcome back to another Turning Tuesday video. As always, I'm Phil Brown with JitCad Cam, and today we're going to go over turning this chess piece in the holiday spirit leading up to Christmas. So let's go ahead and jump into it. So as you guys can see, I have my chess piece here by design. It is a little bit of a different design. However, it is very simple for a turning operation on this part. So what I'm going to do is I'm going to jump over to the manufacturer workspace. We're going to go ahead and create our setup under the turning tab. Don't worry, if you're not under the turning tab initially, you could actually adjust that here. So as you can see, we are turning this. We are doing this in our primary spindle. So not all of us can afford a sub spindle, right? That being said, is we are going to go ahead and flip our z-axis. And the reason for flipping that z-axis is we want to base that off the front of our part. In this case, maybe I'm using a bar puller or a bar feeder. I'm able to fit this through my spindle. Again, every situation is different. However, working off the front of my part is pretty common. So from here, I'm going to go ahead and scroll down. Now, a lot of people ask me about this, and I do get a lot of questions about this. I'm going to adjust my stock real quick just to show you the difference. So a lot of people and a lot of thought goes into the fact of where do I place my origin or where do I place my work offset? Now, commonly, I use the front of my stock. However, if I don't know the distance between the stock and my part, it does throw off the math to my operator to all other areas. Now, I know a lot of people like to face the stock and then use the face of the part in their initial setup. And you can control that right here in the origin field. So if you wanted to use model front, for example, you could use model front. Now, myself, if I'm flipping parts over or grabbing with some soft jaws, I tend to use model back on my next operations, or if this was a slug, again, I could use model back. There's a lot of ways to configure this, but I'm going to stay with what I prefer, and that's stock front. So in our stock tab, you can see a cylinder came through almost identical to size. I'm going to go ahead and open this up to a little bigger diameter. In this case, my fingers are not quite working this morning. We want a nice clean machined edge on all surfaces. So as you can see, that is going to work out well for us. Lastly, in my post-processor menu, if I want to change my program number or my work offset, I have the ability to do so. So let's go in and start our actual process of manufacturing. Very commonly, you would face off your part. I'm going to go ahead and face this off. Let's go out and grab a tool from our default library. In this case, I'm going to go with a CNMT right-handed tool. As you're going to see, that tool is now coming in based on the x-axis from our origin. You can see my insert is face down, guys. So in this case, my turret's on the back side of my machine. My insert was faced up in this situation. You'd want to go with a left hand, not a right-handed tool. Again, that does control clockwise versus counterclockwise as well. But as you can see, it's coming in and recognizing right off the start our geometry. And our geometry is set to the front of our stock or the front of our model, right? Our radii is to start from the stock outside diameter and come to the stock inside diameter. We're not working with tubing or anything, so we could just clean face that off. My passes tab is an insurance policy. As you guys may know, I always turn on multiple passes. And then in the event I want to change my step over, I have that right here. Again, I used very rough numbers because I like to program my part long before I tend to get a piece of stock in hand. But if we change our stock, these parameters will automatically update. So I'm going to go ahead and hit OK. I'm pretty happy with that facing cycle. A few things you may notice about my part versus your part, and I'm going to go ahead and get some things turned on. So one is I'd like to display my in-process stock. I have the ability to also go in and do a rest material or a spun profile. There's a lot of things that you may or may not want to toggle on based on how your fusion looks or the situations you're working with. Now that this may look similar, it may not, like I said, guys, each and every person's different. We can go ahead and start to do our OD work. So I'm going to go ahead and switch over to turning profile roughing. And what's going to happen here is we're going to go ahead and set our geometry. So given how small this material is, and given the size of this, I'm probably not bar feeding, right? So I need to hold on to something. So the first thing I'm going to do is I'm going to change the back location, and I'm going to use a selected edge. Now, given that I know the distance that I can hold on to, I could also do this a little different. I could say, stock back, and then I could actually offset that with the dimension here. So let's say I want to hold 200 off the back. Again, this is to give you guys representation on what's going to sit where, or if you were cutting jaws for this. However, one neat thing here with being able to select this edge, and I can do a tangential extension here. and you'll see where this becomes very, very valuable because the last segment uses that miter. It's going to continue that miter past. So if we flip this part over and turn that OD, we have that ability to just come right back across and not worry about mismatching or blending issues. A little further over, again, we're going to work outside to inside. On our passes tab, I'm going to go ahead and just make this an easy 50,000 depth of cuts. And we're going to go ahead and hit OK, and we're going to see what we get right out the start. So as you can see here, the very first thing I am getting is the ability to go in and actually turn that profile. I am getting what's called, as I like to call it, waterfalling or undercutting as well, because we do have a radial and axial grooving on. And I, for the very rare occurrence, am actually going to leave this on because it will be valuable for some things that we're doing. However, I am noticing an issue where we're not actually going far enough back. So let's go ahead and see what the issue was there. The reason why that's happening is because somebody typed in the number in the offset field at one point and never zeroed it back out. So let's go ahead and correct that by zeroing out that offset. And remember, I said tangential extension past the miter of that corner, and you're seeing that come through. Now, one neat thing here is we are using that CNMT tool. However, if I switched out that CNMT tool to, let's say, a VNMT tool. So here's my VNMT tool. You're going to notice we're actually achieving a lot more on this profile, right? So this works out very, very well if you have the relief on the backside of the tool to access certain areas. So let's change this up though. So I'm actually going to do Control Z to undo that. And I'm going to go back to that CNMT tool. Now, what I'm going to do from here is I am actually going to do a derive. And the reason why I'm going to do a derive into another profile roughing is because I'm bringing through some of this geometry stuff automatically. Now, keep in mind, we do have rest machining here. And with that rest machining, what is going to happen is we're going to recognize where things have not been machined yet. However, I'm going to change things up pretty heavily here because we're actually going to go in and I am going to grab the left-handed version of that tool. And what you're going to notice here is my insert is down with this left-handed tool. That is going to be a key element. Again, my right-handed tool, the insert is down. My left-handed tool, the insert is down. But what's going to happen is we are now going to work in those areas and access the different areas that we can get to with that tool. Again, what you're noticing here is I can't quite get everywhere because of the angle of that tool in the relief. However, what you're seeing here is I have the ability to kind of jump back and forth between a couple of tools to make this happen. So again, is if I go back to that initial roughing, let's say we go with that right hand out the start, and then we go back with our left-handed tool. And just like that, you're going to notice we're now actually cleaning up all of those profiles super quick and easy based on that actual tool relief angle and what tool we're choosing for this situation. Now, one thing that I would adjust on here is, as you're going to see, is we are working still front to back. So this is a little different, right? So what I might actually want to work on this one is back to front because I'm working towards the tailstock, and we can make those adjustments, right? So we can now say back to front. Again, what you're going to see now is this toolpath is going to change up a little bit. But if I go back in and we simulate, now you're going to see that we're working with the backside of the part first. And now all of my tool paths are actually coming in from the left to the right into my profiles, right? So again, this is very valuable kind of information because you never really want to plunge on this edge here of this tool, so to say. And that could cause wear and defect and tool breakage and chatter even based on what you're doing. So now that we've roughed this out in both directions and we've got our clean profile, let's go in and start our finishing information. So what I'm going to do for finishing now is I'm actually going to keep this tool in hand. And what I'm going to do is I'm going to derive this out into a turning profile finish. And in most cases, I like to hit OK to see what I get, right? So again, as if we go ahead and simulate this, we're going to see that we're working from the back of the part into our profiles. And again, as we're able to access all kinds of areas, however, we're still missing very crucial areas again because of the relief of our tool. Now, it's up to you on how you go about this, but I could again derive into another turning finish. And with that turning finish, I'm now going to swap my tool out again back to that VNMT right-handed tool. And we go ahead and hit OK. And now you notice because of rest machining and everything, we're working back the opposite way. Now, rest machining is super valuable when we start to talk about different things here. I'm going to go ahead and turn off a few things here so we can see this a little better. But if I reorder these, so I'm going to go ahead and drag one up above the other. What you're going to notice is my rest machining is actually going to change on a lot of the stuff that we're doing. So again, based off the information here and what we're providing Fusion, Fusion may now actually adapt and change how its cycles are going to work. We could also cut down on machining time with this as well, guys, based on the ordering of what you're doing. So let's take a look at this and see what we get. So again, as we're going to go ahead and simulate this, I'm going to square up. And then for the sake of everything, let's get some stock turned on. And let's slow it down a little bit because I usually go too fast out the start. But as you're seeing now is we're going in with that VNMT tool versus a CNMT tool, and we're roughing out our part with that. Again, you could start with a CNMT, then move to a VNMT. There's a lot of things you could do at the end of the day. But as you're seeing, again, with Fusion, and the great thing about Fusion, we are getting a little bit of a collision up top based on our starting point. We could fix that knowing that we've already finished this top edge by getting rid of certain information. And we'll do that here in a minute, but I'm going to go ahead and hit play to get past this. So again, we went ahead and turned that upper part of the shoulder, and then we came back the other way. Now, to fix this up top, the issue is because we are doing tangential extension and everything, it's actually starting further over here to the left with radial and axial grooving. Again, that comes from the fact that we're doing a back to front motion and things of that nature. So what I'm going to do is I'm going to go in, and the easiest way to fix this is going to be I'm going to go to the geometry tab, and I'm actually going to say, you know, my edge is here versus back there. And now, as you can see, we're no longer roughing up there at the top. Again, I'm going to go ahead and regenerate this next tool path. And as you can see, we're no longer touching anything at the top here. And lastly, if we give this a real quick run through, let's go ahead and simulate with the machine. And I'm going to speed it up this time just to see, because we do have stop on collision on, and we are getting no collisions whatsoever. So like that, we were able to actually achieve quite a bit with a handful of tools that are pretty much standard in any lathe. So let's go ahead and flip our part over and now do the back side and clean up the rest of this part. So what I'm going to do here is we're going to create a brand new setup. We're going to go ahead and leave it in the primary spindle. My Z-axis is pointed the right way. We're going to turn on our continuous rest machining, bringing our stock body through automatically. And now we could just rinse and repeat the back side. Now it's up to you how you guys do this. Usually you already have tools in the machine. So what I prefer to do is actually take them from my first setup and copy them and come down here to the bottom and paste them. So again, what you're seeing me do here is we're just recycling what we've had one way going back the other. The neat thing about this, based on your settings and the way you set up that tool path, remember we did do that tangential extension and things of that nature based on an edge. It's automatically recognized this. So in most cases, setup 2 on your parts, depending on the complexity, tends to be very, very fast, considering you've already got the tools loaded, you've already got the speeds and feeds put into Fusion. It's nothing more than a copy and paste to achieve that. So now if you wanted to move this to a sub-spindle, you could by all means. Another thing that you may want to do is you may want to actually put this to work offset 2, as you're seeing me adjust here. Again, we want to flip that part over in between operations, right? Let's go ahead and add a manual NC here. And what this is going to be is this is actually going to be a stop. And then what I'm going to do is I'm going to stop at the end of everything here. And then I'm going to add another one. We're going to go ahead and put another manual NC in here. And this is going to be flip part over. Again, we need to give our operator as many good notes as possible based on what they're doing. Another one that you can add if you guys wanted to at any time is if you want to move the machine out of the way or do a tool change, things of that nature, we could go ahead and do that as well. So in the case of this, I could actually say pass through, and then I could say, you know, G53, X0, Y0. And again, what that's going to do is that's going to move the machine out of the way so somebody could get in there and access their parts. Now, keep in mind, we want to move the machine first, then we want to stop. And then, of course, we always want that comment for the operator to see. So let's go ahead and post out both programs and see what we get. So what I'm going to do is I'm going to go ahead and grab a default post out of Fusion 360. I'm just going to use this DS30. We're going to go ahead and hit post. We are getting the warning about multiple work offsets. That's more than okay, guys. But what we're mainly looking for here is one, here's all my operational stuff to go in and actually do that profile rough. I'm now looking for is when do we do our actual stop, right? So if I control F, M0, as you're going to see right here, here's my G53 call to move my spindle out or move my turret out of the way, my M0 to stop the machine guaranteed, and then my notes to my operator to flip the part over. So again, it's that easy at the end of the day to be able to jump in and actually create even a little more complex profile with very few tooling that you may have on hand. With that being said, it's always my pleasure to be able to bring you guys the latest and greatest content. I apologize for being out of the office so much lately. People have been scheduling trainings like crazy, and it's hard to get these videos in. However, we're going to continue to make video content. We're going to continue to train. And if you want to support this channel, by all means, hit likes and subscribe. And don't forget, you can buy your Fusion 360 through JitCAD Cam, and you can utilize me as a resource at any time to get your toolpath working or get the training that you and your company need. Like always, it's not what you know, it's who you know. You guys know Phil Brown here at JitCAD Cam. That said, have a great rest of your day.